Neural networks are a cornerstone of machine learning. Whenever you hear about AI, you hear about neural networks in disguise. But what are they and how to use them? What started as an analogy to how a human brain works, now became a totally independent concept. In 1950s, as computers advanced into their infancy, it became possible to begin to model the fundamentals of theories concerning human thought. Nathaniel Rochester from the IBM Research Laboratories led the first effort to simulate a neural network. That first attempt failed. But later attempts were successful. Advocates of thinking machines continued to argue their cases. In 1956, the Dartmouth Summer Research Project on Artificial Intelligence provided a boost to both artificial intelligence and neural networks. One of the outcomes of this process was to stimulate research in both the intelligent side, AI, as it is known throughout the industry, and in the much lower-level neural processing part of the brain. In the years following the Dartmouth project, John von Neumann suggested imitating simple neuron functions by using telegraph relays or vacuum tubes. This was to be the first AI revolution, and then came the winter as the results were far from satisfactory. We've seen revival of AI in the 90s, but it again failed due to insufficient infrastructure. Everything changed in the last decade. Syrison and colleagues showed in 2010 that GPUs make backpropagation feasible for many layered feed-forward neural networks. Between 2009 and 2012, neural networks began winning prizes, approaching human-level performance on various tasks, initially in pattern recognition and machine learning. Syrison and colleagues built the first pattern recognizers to achieve human competitive/superhuman performance on benchmarks such as traffic sign recognition, which was published in 2012 and is usually counted as the start of the AI revolution as we know it today. Neural networks start with perceptrons, modeled on a single neuron in a human brain. You can think about it as a couple of functions composed one by one. You have the input data, then you apply an activation function, that can be a linear function, ReLU or a sigmoid function, or anything else, then you pass the data to the next node and again apply the activation function. Is a class of feed-forward neural network. A feed-forward neural network is a neural network wherein connections between the nodes do not form a cycle. Backpropagation is an algorithm in training feed-forward neural networks for supervised learning. Backpropagation computes the gradient of the loss function with respect to the weights of the network for a single input/output example. In this context, it's also important to understand gradient descent, which is an algorithm used to find a local minimum of a function. Let me note here that deep learning is machine learning, but with neural networks of at least 3 layers of a neural network we use. Though the concept of neural networks is old, as a practical domain artificial intelligence is very new, barely reaching 10 years old, if we start counting from around 2008 when most nowadays era results started to appear. This makes neural networks extremely fascinating as a domain of study and applications. We're just learning where we can apply them and how. Data science and machine learning are both growing to be the biggest and hottest domains of computer science, with many applications yet to be discovered. Finally, if you want to have an overview of what it means to be a data scientist, then have a look at my book Data Science Job: How to Become a Data Scientist, which will guide you through the process.